Hi, I'm an old guy and I do maths. How do you find the volume of this pyramid? Well, if you know all the relevant measurements, then there are two easy ways. The first is the volume is equal to 1/3 of the length times the width times the height, or the area of the base, because length times width gives you the area of the space, times the height. Now, what is missing from this is height. What we do know is we know the length of this sloping side here is 13 meters. That is not the height, though. The height runs from somewhere in the middle here up through the center of the pyramid to the apex, and it will be a different measurement. It'll be less than 13. Let's just put it that way. Okay, so how do we go about finding that? Well, just let me sketch up our problem very, very roughly. This is indeed very rough. So we've got the other constituent parts of the base there, and if we dropped a line from the top of the pyramid here, it would hit somewhere down here, and if we looked at it from above, it would look like this. And we would be able to draw a diagonal line across the base of the pyramid. We know that that's 10 and that's 10. And so we could work out this length across here. Now, why is that important? Well, it's important because if we know this length, which we'll call x, we know this length, which is 13, and that length there translates to there on here. We can draw a line up there and we have a right angled triangle. And so translating that in part, or rather this to here, let's get things in the right order. We need to work out what this is before we can work out the height. So let's work out what this is. This is 10, this is 10, and we'll call that c. A squared plus b squared equals c squared. So 100, 10 squared, plus 100 equals c squared. So c is going to equal the square root of 200. Now, what is the square root of 200? Well, it's somewhere between 10 and 15. Well, it's actually somewhere between about 14 and 15, because I think 14 squared is 196. You can correct me on that later. 15 squared is 225. So let's find the square root of 200. There it is. 14.1421, we'll say. 14.1421. And that's meters. Okay, so we know this length here is going to be half of that, because we want from there to there, not all the way across. So what is that divided by 2? 7.0710. So 7.0710. And again, you can see why I use a scrap of paper for this. We're now going to draw not this triangle, which came off here, but this triangle. Just get that in frame. This triangle that goes halfway across there and straight up. We know that that's 13. We now know that that is 7.0710. And we can use a variation of Pythagoras. If this is A, we can call this B, and we'll say that that is C. So we can label them just for your reference here. But what we know is that C squared minus A squared is going to equal B squared. It's just a little bit of algebra. If A squared plus B squared equals C squared, then C squared minus A squared will equal B squared. That's what we're looking for. That is the height of our triangle. Okay, so c squared, 13 13s, 169. Don't ask me what this is. It's 50 something, because 7 7s are 49, 8 8s are 64. It's in there somewhere. 7.0710 squared is 49.99, near enough to 50, but we'll go with 49.9990, and we'll subtract that from 169, and we get 119.0009, near enough. We could really call that 119 for the purposes of this discussion. Now note, we started over here with a formula and a problem. Our problem was to find that. Once we find that, we can come back here and do a very simple piece of working to find out the volume of this thing. All the work is in here, finding h. Okay, so what we know is that b squared equals that. So let's find the square root of that. The square root of that is 10.9088. 10.9088. And that is meters. And it is that, which is that, it's the height up there, which is this, the missing number. 10.9088. And we can take that now and put it into either of these formulas, and we will find the volume of this. So let's do that. We'll do this one. Now I got asked by a student, actually the student who gave me this problem, why I do this and not multiply by 1/3. It's just more convenient. It's easier to do on a calculator. Righto, I've skipped ahead a little bit and worked this out. It comes to 1090.88 meters cubed on 3. Pop that into the calculator. That's what I get. Can you see that? Just got to work around the lighting here. So that is 363.63, we'll call it. 363.63 meters cubed. And that is finally how this gets done. So, in fact, had we known the height of this thing, we would have done this remarkably quickly. Now, the basic idea is, just to go back over it, that the volume of a pyramid like this is 1/3 times the length times the width times the height, or 1/3 of the area of the base times the height. And jumping a little bit ahead to another possible video, when you're faced with a cone, again, it's going to be 1/3 times the area of the base times the height, which, if you translate that into conical terms, the base is a circle, so it's 1/3 pi r squared times the height. But we'll get to that at some stage. Anyway, thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.